Map scale. What's a map scale? What? A map scale? What is that? Map scales show the relationship between the distance on a map and the actual distance on the Earth's surface. So when we're looking at maps, we know that they're showing us a condensed version of a particular area. So these tend to be much smaller distances on the maps that represent a much larger distance of the Earth. Right? Right. So there are three general types of scales that we will consider. So the first one is simply a direct statement. It just uses words to describe the relationship between a distance on the map and a specific distance on the Earth's surface. So the example, or just an easy example here would be 1 to 10, or 1 centimeter to 10 kilometers. Or another way of saying this would be 1 centimeter equals 10 kilometers. This is a fairly straightforward scale that we can use. Again, usually used more along the lines of oral conversations. So if I was to say 1 centimeter on this map equals 10 kilometers, you could take a ruler and use just what you've heard or say read to determine what the actual scale would be. Again, straightforward. The second is a linear scale. You might have seen these on some maps. You most likely have put them into your GIS map of Canada, so this shouldn't be too foreign for you, but it looks like a ruler. Well, it is a ruler. It's a special type of ruler on the map, and it's usually divided into equal units of distance. And this allows us to use that linear scale that would be on our maps to determine what the actual measurements would be from our map to our Earth's surface. So the difference with this one is that it always includes the unit of measurement on the Earth's surface. So we are always looking at what the actual measurements are going to be. So you tend to see that these numbers will change quite a bit depending again on what scale. I'll show you an example of that next. The third and last type of scale is a representative fraction. You would also know this as being a ratio. So a representative fraction, or an RF for short, because representative fraction, it's tough. So essentially it's a ratio where one unit on the map equals a specific number of the same unit. Okay, keyword is the same unit on the Earth's surface. So it's always done as a ratio or as a fraction of 1. Always. 1 to 50,000 is what this fraction or what this ratio is saying. 1 to 50,000. So 1 centimeter on our map equals 50,000 centimeters on the Earth. Now that's all fine and good, but we do tend to run into a few problems with this type of scale. It would be difficult for us to consider 50,000 centimeters or 500,000 centimeters or 1 million centimeters or 1 billion centimeters. It would be tough for us to use that as a measurement unit, right? Exactly. So sometimes we can convert these. Okay, so there is some math involved, so get ready. So an example, if we were to say that our map scale is 1 to 50,000, again, we're saying 1 centimeter is the same as 50,000 centimeters on the Earth's surface. So hypothetically, if we had a town, A, and it was 10 centimeters away from town B in a straight line, one way of converting this to something that could be a bit more manageable would be to take our ratio, 1 to 50,000, and then in this particular case, we have a bracket, so we know that we are multiplying by 10 because we've measured out 10 centimeters from town A to town B. So we know that there's 10, we can do our simple mathematics, and we know that this would end up working out to be 500,000 centimeters. So town A is 500,000 centimeters from town B. Now, do you know exactly what the distance of that would be? Probably not. Most people can't really think of 500,000 centimeters or 1,000,000 centimeters. It's just too crazy. So again, we could take this and break it down into something that's more manageable. Again, simple mathematics and unit conversions. If you're a little unfamiliarized with it, you will get reacquainted. So again, another way here they're saying at the bottom statement would be, so town A is 500,000 centimeters, or in which case 5 kilometers from town B. Really? Hey, teacher guy on the mic who I don't know. It's Mr. Evers. How do I get 5 kilometers? Well, again, just some simple conversions that you might want to keep in mind. Okay, so write all of this down. 100,000 centimeters, 5 zeros, 100,000 centimeters equals 1 kilometer, right? So kilo, 100,000 centimeters equals 1 kilometer. So a simple way to remember this is obviously just when we're switching from centimeters to kilometers, so we want our number to get a little bit smaller, we divide by 100,000. And on the reverse of that, if we are looking to go from kilometers to centimeters, you would then multiply by 100,000. Okay, you will get some practice with this, so just take a peek. I am going to show you, if I can. Okay. So I'm on Google Maps, where this is what you're looking at right now. Point A that I've clipped on is actually in Kitchener-Waterloo. This is the town that I am living in. So one thing that I want you to pay attention to is the bottom left corner here, where I am zoomed out to a point where we can say that our scale, what type of scale is this? It's a linear scale, exactly, is representing 200 kilometers. So from here to here is 200 kilometers of the actual distance on our Earth's surface. Disregard the miles. So 200. So I'm kind of far out, and so we're using a much larger distance. Now I'm just going to zoom in slowly. So we're at 100 kilometers. Okay, well, what is one thing that we can notice as soon as we've reduced our scale to half? So we've made our scale smaller. What is one thing that we can maybe tell has kind of happened? Just ask it in your head. I'll give you the answer. Some detail. So you'll probably notice we can see some roads. Road networks have worked their way into this. I'm going to zoom in some more. Okay, you can still see now we're looking at a few more towns located across, a few cities. I'm going to zoom in a little bit more. We're starting to be able to see the GTA region in here. You can see a little bit more of the urban area. Out in the rural areas here, you can see that there's a clear distinction of farmland. So I'm just going to keep zooming in. We're at 10 kilometers now. So it's saying here to here is 10 kilometers of distance. Zooming in more, zooming in more, zooming in more. All right, I'm going to bring you right in. You can see where I live. Don't try to find me, though. I know. Don't find me. This is the townhouse that I live in. So I'm sitting at about 50 meters would be this actual representation. So 50 meters, I could tell that this would be about 50 meters length, my townhouse, maybe a little bit longer. So the key thing, the reason I'm even showing you this is just you got something else to keep in mind. You have what's called a large scale map and what would be called a small scale map. Okay, so a large scale map means that you're generally going to be looking at a fairly small area. And when you're looking at these small area, you might tend to find that there's a lot of detail. So we would consider, I know that the number tends to seem like it gets smaller, but even if it does get smaller, we still consider this to be a large scale map. Okay, a large scale map. So again, zoomed in, then when I'm at 20, I've even zoomed in even more. You can tell that I have a pool that's really cold. You can see my roommate or my neighbor's car, that is white. You can tell that this might be a busy street. With a large scale map, you can tell that there's detail. You can make that stuff up. Now from a small scale map, now it's much more vague, right? You can tell that there's less detail. We're looking at a much larger area, okay? But again, less detail. So large scale, lots of detail, very small area. Small scale, large area that we get to see with very, very little detail. Okay? If that was a bit too much, I am just going to jump on in to this gentleman's quick scale conversion, because I find that he does a pretty good job of kind of wrapping up a few things. All right.
The map scale is the relationship between distances in the real world and distances on the map. The scale can be displayed in different ways. These both mean the same thing. 1 unit of distance on the map equals 24,000 of the same distance units on the ground. It doesn't matter which units are being used. It could be centimeters, it could be the width of a pencil. The ratio of 1 to 24,000 is the same. Now sometimes it's useful to convert the ground units to something else. For example, we know that there are 12 inches in a foot. So if we divide this by 12, we see that 1 inch on the map equals 2,000 feet on the ground. That's a lot easier to deal with than 24,000 inches. We could, also convert this to miles, meters, kilometers, or whatever.